I'm handing you over to Faas. Have a lovely time.
Was the king? All right, give me 1 second. Need to have them there. All right, I'll stand over there. Well, good evening, everyone. Thank you all for being here with us today. I'd like to start by thanking Josh for allowing me to be here with you today. So thank you, I appreciate. Thank you also to the sponsors. And so we're going to talk about exceptions today, or maybe not, maybe a little, I don't know, we'll see. It's going to be a pretty technical session. We're going to have a lot of code to talk about, code in C#. So I assume it should be okay for most of you. If you're not a C# developer, relax. I'm not going to use any fancy stuff, just class functions and generics. That's all. So should be good, right? So the first question you might have is, who's this guy? Me. So my name is Guillaume. I'm a .NET developer advocate at Vonage. And I come from France just to see you. So this is why I speak with a weird accent. This is where you can find me online. So GitHub, LinkedIn, the usual suspects. I also have an additional GitHub account there, which is a free organization that we made with a friend in order to share what we know about extreme programming, TDD, and other things. Everything is free and open source, so have a look. And I'm also the host and organizer of the Software Craft Luxembourg meetup. So we're still operating online. If you want to jump in, feel free. If you want to talk, reach out to me and we'll make it happen. All right? So, exceptions. Quick show of hands. Can you raise your hand if you had to deal with exceptions at least once in your career? Everyone. It makes sense. Expected. Okay. So today I want to focus more about the error handling side of things for exceptions. And just as a reminder, exceptions are a way to deal with unexpected and exceptional situations. Right? So you have an exception somewhere, something bad happened. That is at least on paper, because something that I've observed among the years is that we tend to overuse them, especially when it comes to validation. And this is something I want to focus on today. And I'm going to rely on examples of things that I've seen on a daily basis, trying to show you something a bit different. So if we start assuming, by the way, how's the code in the back? Good enough? Cool. So assuming we have a service that is there to retrieve a user from a data store by email, let's assume we have that, right? Where you can just retrieve something, and at the top you have a guard clause, right? So if you try to retrieve something and you pass either an empty string or null, you get an exception. Why not? So guard clauses are awesome. They are a way to make sure that the input you receive matches your requirement so that you can use it properly. So all good, except it's an exception. It's not exceptional. It's not unexpected. It's there. And you'll see what the problem is. So when I want to call this code, and I call user equal service.find user with an email, what do you get? You can't be entirely sure. You might get a valid user. You might get null. You might get an exception. An exception of which type?
So it might also not exist.
Sorry? That's also something else, but we're assuming that we're on the right track. So, but that is correct. So what's the problem here? We have a transparency issue, okay? When you look at the method signature for find user, so user, find user of string, it doesn't tell you everything. There is no exception in there. In Java, they have checked exceptions for sure, but we don't have that. So when you call this, you have no clue something is happening. The method is kind of lying to you. All right? So what's the consequence of this? Defensive programming, yay, try catch everywhere. Who likes it? You see, everybody's laughing. So when you throw something, it's very easy, right? The problem is you're throwing the hot potato to the person that's going to use your code. That's not a good team spirit, okay? So in our case, you don't even know that something may be thrown. If you don't put that try catch block and you get something, guess what? Your software crashes. That's bad. So just in case, you put a try catch block, and as you still don't know what to expect because it's not clear from the definition, you use a global exception type, which is a bad thing because you don't know what to expect, right? And then you have additional logic to deal with the user, which is fine. So something you can see there is there are two sides of a coin. One is writing the code. The other one is using the code. The code of the service is fairly simple. If statement with the first of default after that. Fair enough. Using it, it's quite convoluted for such a simple scenario. And we are throwing one exception. We only have one dependency there. It's extremely simple. So yeah, I'm not a big fan of this. But exceptions have become the de facto standard when you want to deal with validation. What I want to show you today is something maybe a bit different that doesn't rely on exception and that focuses more on transparency. And I have to apologize because we're going to talk about monads. So don't cry, right? So monads are a construct that comes from the functional paradigm. And as everything in that paradigm has to be over-complexified. Now, to give you an example, this is our definition. I'll get back in 30 minutes. Okay? No, it's exactly what we're not going to do, right? I'm going to try to stay away from category theory, from math or anything complex, because I'm not a genius, right? I'm just a developer like any of you. If I can do it, you can do it. Okay? So bear with me. We'll try. The first thing that we have to try to do is there is a middle step that we have to go through before going through monads, and it's a functor. If there are any hardcore functional developers in the room, be kind with me because I'm making shortcuts, big shortcuts. I'm trying to simplify because I want people to join the party, So it's on purpose. So imagine a functor as a wrapper around a value, like a box, okay, to which you can map a function in order to change the value. Doesn't make sense? That's all right. The monad is a functor that you can change. Doesn't make sense either. We're fine. I'm going to use a very simple example that most of you should know, I guess, from quantum mechanics. I said simple. Schrodinger's cat. You have seen someone with a t-shirt saying the cat is dead and alive at the same time. You must have. Not exactly that, but yeah. So Erwin Schrödinger, physicist, Nobel Prize winner. So smart. What he's trying to say with that is, so you have a box and you have a cat. Now it's not your ordinary box from Amazon because the box is trapped. It contains two things. One is a radioactive element, and the other one is a mechanism that can release deadly poison at any time without you being aware of it. So what Erwin is telling us is basically, if you put the cat inside the box, the only way to know if the cat is dead or alive is to open the box again. Smart. Actually, so what Erwin is trying to explain there in simple terms, is the principle of quantum superposition. In quantum mechanics, until you can observe the state of something, you have to assume it can be in an infinity of states. You just don't know. Here it's simplified, not an infinity, 2, dead, alive, right? So until you can observe the state of the cat, you have to assume it can be either dead or alive, and in the meantime, you can still use the box. That is all. And as I have a very boring life, I coded a box like that. Okay? Here it is. Nothing too complicated. Let's start from the bottom. So we have 2 factory methods. One to create a box with a dead cat inside. It's going to be a fun talk. Yeah. And one with a cat inside. So cat here is a struct. And as you can tell, on the first field of the class, cat is followed by a question mark. So here we say that cat is nullable. This is to tell you that basically having an instance of a cat means that the cat is alive, and if you have null, the cat is dead. And you can't instantiate the box unless you use those factory methods. Okay? Now what can we do with such box? First, you can shake it. So inside you may have a living cat, you may have a dead cat. What we do is we call meow on the cat, the meow function, which logs meow in the console. Extremely creative. But you see there is a question mark there. Because if you shake the box and the cat is alive, it will meow. If you shake the box and cat is dead, nothing happens. So here, if cat is null, nothing happens. We don't call meow. If cat is alive, we call meow on the cat. And then we return the box. Second example, you shake a bit too hard. So same goes, you call shake, but you return a box with a dead cat inside because you just killed the cat. And finally, you can open the box. This is where you can see the state. This is where you can observe the cat. There is no other way than open box to see the cat. So, example. You have a box with a cat inside and you call shake, shake, shake. What you see in the console is meow, meow, meow. Fair enough. And when you call shake, shake too hard and shake, you get only 2 meow because on the third one, the cat is dead and the dead cat doesn't meow. So, makes sense. Pay attention to something, and I want you to keep that in mind for this slide and for the few ones that are going to come. Notice that you never actually manipulate the cat directly. You always call shake, shake too hard, or something like that. And the flow is always the same, right? Keep that in mind. So what do we do? Because I won't go far with that box of cat. If you want to do that, to implement that in your financial application, let me know. Curious to know how it turned out. So we have a box with a cat inside that can be dead or alive. Now, we could replace cat by anything else, like a T, a generic. So an integer, a person, a dead time, whatever you want. We do have one problem. If I have a box with 3 inside, having a box which is dead or alive, a value that is dead or alive makes no sense anymore. So we have to change the way we see states. And let's change to none or some. So either I have a value in the box or I don't have a value in the box. So not a lot of changes. Most of the box remain the same. One thing will change, and no more shaking. There is no need to shake anymore because it's fun is gone. Let's talk about serious stuff. And so we replace shake by a method called map. Map takes a function as a parameter. Ooh, scary. Actually, not so much. So what we're going to do is, when you call map and you pass a function in there, we're going to verify in which state we are. If you're in some state, you have a value inside the box. What we're going to do is apply the function to our value and return the result in a new box. And if we don't have a value, we're returning nothing, an empty box. like we did with shake. How does it work? A box with 3 inside, and I call map of value lambda value plus 1. That barbaric expression is called a lambda expression. It's a function. The value is the input, and what's at the right side of the lambda is what we return. It's basically an increment method. So when I have a box with 3 inside, and I call map value lambda value plus 1, what happens is I open the box, I get the value, I do have a value, so I call increment, 3 becomes 4, put 4 in the box, and pass the box around. So 3 becomes 4, 4 becomes 5, 5 becomes 6, and when I open the box, I get 6. And when I have a box with nothing inside, you open the box, there's nothing to do, you return an empty box, and at the end you get 0. Again, you never touch the value directly, and the flow remains the same. The only thing that changes are the input and therefore the output. Keep that in mind. Time to celebrate. We just made a functor. That was so complicated. Can't believe it. Now, I don't know if a few of you have seen it, but it's still fairly limited. A problem we have with our functor is that states may never change. If you're in a sum state, you will always return a sum state, and if you're in a non-state, you always return a non-state. It would be cool if we had something that allows us to change the state, right? Let's look at bind, which looks very similar to map. One slight difference. When you call map, the function you pass transforms a value into another one. And we wrap the result into a box. The function you give to bind transforms a value into a box of a value. A box that may have a different state. Okay? Let's look at an example. We have a method there called half that is trying to get half of a value, half of an integer. Okay? So we're verifying, can we divide by 2? If so, we return half of the value in the box, and if we can't, we return none. Fairly simple. If I have a box with 8 inside and I try to get half the value 3 times, 8 becomes 4, 4 becomes 2, 2 becomes 1. And when I have a box of 4, I'm doing the same. 4 becomes 2, 2 becomes 1, 1 becomes none, and when I open the box, I get null. At the beginning, both our boxes were in the sum state, and in the second scenario, on the third half, the state changes from sum to none. That's pretty cool. Actually has a name. It's called railway-oriented programming. Has anyone heard about that before? Yay! No, that's cool. That's exactly what we've seen. This is a visual representation of what we just done. Okay? So, as you can see, map, transform in the middle there, one value to another, and will always return the same state. See that as a select in link queue, for example. The same thing. But when you call bind, something may fail. And so that representation shows one railway track per state. Some is our success state, none is our failure state. And so the idea is, if you want things to get executed, you have to remain on the green track. As soon as you fall off on the red one, nothing gets executed anymore. Okay? This is something that you could do normally with regular if-else statement. It's just a different representation, a different way of presenting that. And it's just what we've done. As you can see, half may return none, while increment being what we pass to map just transform the value. And so, with that, congratulations. We just made a monad. So I really tried to stay away from the theory in there. Josh, you let me know about the pizza when you want to do the. So how was the break? Good enough? Cool. Do you need me to go over the 20 minutes again? Or can we? No? Okay. We're just getting started. So we just made a functor with bind, monad with bind. And as you can tell, it's not as complicated as it looks, right? Now, even though we got a monad, why should I stop there? Because I still see a lot of problems in our box right now. Because right now when we open the box and we have nothing inside, we get null. I hate null. It's a billion-dollar mistake for a reason. So we need to find another way to extract the value from the box without relying on null. Now, how do you represent the absence of a value without relying on null? Well, you don't. What you can do instead is provide a fallback mechanism. And so this is what match is about. Match doesn't take one, but it takes two functions as a parameter. Gets crazier by the minute. Now, actually, it's fairly simple. We have one function per state. One that will be used if we're in a some state, and one that will be used if we're in a non-state. So when you call match, it's fairly simple. You give two functions, and given on the state we're in, we're going to call the right one. In that case, I have a box with 3, increment 3 times, get 6, get half of it, get 3. And when I call match, I provide two options. What happens if I'm in a sum state? I'm returning the value is sum with the value. What happens if I'm in a non-state? I return the value is none. In that case, I'll get the value is sum 3. And if I have nothing inside, so I have 4, increment 3 times becomes 7, try to get half, change of state, we get none. And in that case, we get the value is none. No more null, happy me. But by fixing a problem, I kind of amplified another one. Because if you're like me, you see functions, 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 functions. Right, a lot of functions, a lot of identical functions. So my kind of urge right now is to extract them. So if by any chance you get a JetBrains license today, simple, Control RM, extract method, and you get this. Okay? Let's put a name on some logic. Now it sounds very simple, but that is just insane. Why? Because what you do matters more than how you do it. Right? When you can put a name over logic, you can express intent, something that is not explicit or obvious through the code. You can tell what or why you do it. Right? The how is an implementation details. Nobody cares about it. It's just noise that you don't need at first glance. Right? So when you do that, this is what you get. It's called declarative writing. The code looks like a story that you can read. All right? And so assuming the person that you show that code to understand what map, bind, and match do, show that to a junior or someone who's not technical, they will understand. A box with 3, increment, get half of it, do whatever. It's fine. It's like reading a book. You have the chapters, and if you want to see the specific, how do you increment? Go to definition, open the page. That's simple. That's a huge trick if you want to facilitate understanding and maintenance on a code base. It has nothing to do with monads, but it relies so much on functions that it goes well together. It would be a shame not to talk about it. One more thing that I want to show you. I'm sorry if it's small for people in the back. Sorry about that. That's the last iteration that we have on the box. So one process plus the functions. This is the F# equivalent. I'm not saying it's identical, but it's very close. And so suddenly, you're that close to jump on another language from another paradigm while still having the .NET framework to back you up. If you're interested into learning a functional language, you will never get a better bridge than that. Try Haskell? Yeah. Tell me about it. This is fairly easy. As Scott Blashin used to say, F# is like C# on diet. Remove the fat and this is what you get. So, just to sum it up, what's Monad? Well, you've seen it. Something that wraps a value that you can chain together. It has states, you can change the states, and you don't know what's in the box, but you can still manipulate it. Yeah, that's my definition. Might be inaccurate, but works. Now, the thing that you might say is fairly simple, what we've seen today, some addition, some division. Yay, use that when trying to calculate transaction costs on an application. So we're going to see some real life applications. And the first thing I want to show you is everything we did, or I did, you don't have to do it. Because you have libraries that offers Monad for you. The most famous one is Language X, written by Paul Luth and a lot of people now. It's also the most overwhelming one. So be ready, because the documentation is very difficult to get through. So buckle up. There are another few. And even if you do other languages, if you're on Java, you have Vavr. If you're on TypeScript, you have FPTS that also offers a few of them. And so I wanted to show you a few Monads that are available to those libraries. So the first one is option maybe, that represents an optional value. So the states are some none. Should sound familiar. It's the one we did, right? You have try, that will basically wrap a process that may throw an exception. If it throws an exception, it'll have an exception state. You have the result, which is a failure and success. You have the either, which gives you complete control over the two sides. And the one of that row. We won't talk about it today. So, funny thing, if I take the first example I've shown you with the service that was trying to find the user that was relying on an exception. If I was trying to get rid of that exception and use Monads to do the thing, what could we do? Let's look. First off, what I want to do is to deal with that nasty quad clause that we had before. So I made a class called findUserRequest that is read-only, that you can't create by yourself. It's using, again, the parse static factory method that will create an either of parsing error or findUserRequest. So if the email is null or empty, what we're going to return is an error saying that, hey, you can't provide an email that is empty or null, for example. And if it's valid, we return a proper request. This stuff is called parse and validate. It doesn't mean we don't do validation, but we do parsing inside. The idea is, with this, you cannot create an invalid findUserRequest. If you find an instance of findUserRequest somewhere in your code base, you know it's valid, because something invalid would have produced a parsing error instead. That's a big deal. On the service side, when you try to retrieve the user, as a parameter we get the request, and depending on whether we find the user or not, we return an option of user. May have a user, may not have a user. Two states, some and none. Now what if we try to put them together? Fuck it up. So first we create the request, okay? So again, either of parsing error or findUserRequest, and then if I map that to my service, I get something very strange. I have a monad that contains a monad. That's crazy. has no limit. So first off, you can chain them. Now, the reason we do this, it's not the only way, it's maybe not the simplest way to do it, but what I want to explain. Remember, we have three possible outcomes. Either we have a valid user, either the email is invalid, or we have a missing user. In the context of an API, I need to be able to make the difference between those two errors. Because having a missing user, I must return a 404. If the email is invalid, I must return a 403. Right? So I want to keep those branches separated. So like this. First off, I got my either. On the left side, if it failed, I'm calling whatever thing to do when it failed. And if it's a success, I need to evaluate with match again the option to do whatever I want to do when the user is missing or found. One way to make that a bit easier is to put the parsing error and the user not found on the same scale if you want, and you would get only an either of error and user. It would be a bit easier, but you would lose the granularity of what do I do with the errors. So that's the thing. Now, I want to show you how I use them. And to that, I need to explain to you a little bit of my context so that you know what is the scope of action that I have. So at Vonage, what we do is we offer APIs to people. Okay, so we have communication API to send text, video, or make voice call, or doing two-factor authentication, these kind of things. And we also offer mobile network APIs where you can see if your number has been the target of a SIM swap attack, or if you want to have a device location or a device status, these kind of things. APIs, right? So APIs mean you can just do a call request to make something happen. You can run Postman and run a request, or you can build your own HTTP client and do it yourself. But it's boring. A lot of boilerplate. Nobody wants to do it. So what we do is we put tooling in the middle. Tooling as SDKs, libraries. So my job is to maintain such SDKs in .NET. We have similar SDKs in other languages or other frameworks like Node, PHP, Java, Python, others, right? So now you see what my scope is. Trying to make an HTTP request simple, okay? And it starts from getting the data, the first thing that we have to do. For example, let's say we have a two-factor authentication process and the customer just received a text with a code that he has to fill. You, as a developer, what you have to do is get that code plus a request ID and send it. In that case, my data is code and request ID, for example. So parsing, you're familiar with that? Either we get a request or we get a failure. Then I need to convert that to an HTTP request. Sounds simple, but it may fail because this is where I generate the JWT token for our API. It may fail if credentials are invalid for the customer, for example. And then I need to send it to the client, to an HTTP client, and then I get the response back. And I need to deserialize it. Looks crazy. The thing is, when you send an HTTP request, you will always get an HTTP response. Okay? So in my case, I need to decide, this is where I have map on the send request, but then no matter what I get, I need to deserialize it, whether it's valid or not. That can fail as well. I end up with 4 tracks, one being valid, 2 other being deserialization issues, and the other one being an HTTP failure. So yeah. And then when I have the final response, whether it's good or bad, I give it back to the person using the SDK. And I'll guide you through the code. Now it's going to be a bit intense and we won't have time to go through everything, but parsing, you've seen that before. The only difference here is I'm not using a parse method like before. I'm using a Fluent API that I made to create a request. Other thing, the monad you see there, we haven't seen that one before. It's normal, it's because it's one that I made. I didn't use LanguageX, even though it's my favorite libraries. The main reason is I didn't like the way they handle async, and I wanted to do it differently, so I made that one. And there's another reason for it. I'll tell you later. So That's basically the idea. Transforming it to an HTTP request, fair enough. And this is where it starts to hurt a little bit. Because I said before, when you get an HTTP, when you send an HTTP request, you get a response. But if I get, let's say, a 403 or a 500, I'm still on the green path because it will never throw an exception. So I have to kind of force my way into it. This is why on the last bind, you see a ternary operator to kind of force the way to the red path, and then deserializing whether it's a success or a response. And this is how it looks like from the caller's perspective. So the parsing, you've seen it before. What's after that is bind with verify the code, you get the result, and then with match, you decide what to do depending on whether I get a success or a failure. Now, if you remember what I mentioned before, there are like two sides of a coin. One is using the code, the other one is writing the code. My first priority is to make using the code easy. Then writing the code, it might seem a bit complex, mostly because I think if you're not used to it, it looks complex. While you're in it, just fine. It's like riding a bike. And so trying to make the developer experience easy there, it's very difficult to make everybody happy. Because writing an SDK, I need to make decisions, right? So I want people to use it this way. Some people might want to use exceptions, which is fine. So what do I do? Because I can't make everything twice just to make sure that everybody's happy. So what I did on my custom monad there is to implement a new function called get and save. That will unwrap the value by default. And if the monad is not in the right state, let's say it's in a failure state, it will throw an exception with the right type. And then if you want to deal with it, deal with it. Okay? Now, should you get rid of all exceptions ever? It's a bit more complicated. Because like good old Thanos over there, exceptions are inevitable. Whether you like it or not, they will happen. Sometimes in code that you wrote, and sometimes in code, no, and a lot of time in the code that you don't own at all, right? And I'll show you that, because actually even Thanos got defeated by exceptions. So what can you do about it? I need your help right now. Can we all pretend this is an hexagon, please? It's a circle, I know. Who heard about hexagonal architecture before? Yay! Good. Good. So it's an architecture that was, I think, what happened in 2002, 2003, something like that. It's a domain-centric architecture that later gave birth to Onion and Clean. So the idea is that hexagon is your domain, your business logic, what makes the value of your product. We put everything there that is business related. And at the edges of that domain, we have what we call ports. They are contracts, right? Interfaces that define the requirement for the domain to work. And on the left side, you have what we call driving adapters. They are the starting point of your application. So front end, back end, API, service, desktop application, whatever. And on the right side, you have driven adapters. They are your dependencies, everything external to your system, thing that you don't own, but thing that you need to make it work. File system, third-party API, database, devices, anything, okay? And the thing is, those dependencies, they will throw a ton of exceptions, okay? Whether you like it or not. And so, when one exception happens over there, it will, bubble up. And you might think that I see problems everywhere. Maybe I think too much. But for me, having a domain that is supposed to be agnostic of its dependencies isn't supposed to have to deal with an entity framework exception at some point. I don't like that. It doesn't mean we don't have any solution. Because what you could do is, inside your adapters, you could catch the exceptions and make sure that they don't propagate using monads. This way you're able to write an exception-free domain. Adapters, you can't do anything about it, but it works well. There's one small caveat. The driving adapters, they will throw exceptions too. Whether it's ASP.NET or anything like that, they will throw them as well, but at least they're not going inside the domain, so that's fine. So, why did I wanted to show you this in particular? I wanted to give you another tool, because we all, along in our careers, build our own developer toolbox that we carry with us that contains tools, frameworks, methodologies, practices. It's called experience, okay? And the more tools you have in your toolbox, the more suited you are to take a good decision for specific problems, the more options you have, right? And so, should you throw exceptions or should you use monads? I'm sorry, nobody cares. You did not just lost an hour, all right? No, there is something there. We work in a complex industry where the only absolute answer is it depends. It always depends on something. The team, the context, the client, the stack, whatever. It depends. And this is a quote that I read a long time ago in a blog post from Mark Simon. He's one of my heroes. He wrote that in 2014 in a blog about CQS, command query separation, which is a very important practice in OOP. And so, even though it's extremely important to apply that practice as much as you can, he was clear about that sometime he was breaking that rule on purpose, but he was knowing he was making a trade-off. And as usual, Mark is right. Okay? You could decide to break CQS by use exceptions or use monads. It's exactly the same idea. What you use, nobody cares. What's important is why you use it. If you decide to pick one over the other, why? Are you sure about the trade-off you're making? Are you sure you're picking the best decision? So what I want you to do is not either use exception or monads. What I want you to do is practice and experiment. You need to be able to make a proper decision. And when you make that decision, you need to be able to explain it to your peers and defend your ideas, right? So if you have one takeaway to take with you, it's this, not the monads. Now, if you want to go a bit deeper in that, I've written a series of blog posts on monads where I have much more room to go deeper in the topic, and it's still ongoing. Also, I wanted to share with you all the resources that either I used or inspired me for writing this, including a set of books. One should be familiar because you had Simon Painter a couple of months ago here. He's a great guy. And so this is all. I would like to thank you all. I will just move to the next slide. This is a QR code where you have an extract of all the slides, plus a file with all the resources I shared. If you want them, feel free. So thank you all. I really appreciate that you came here with me. I hope you had a great time. I hope you learned something. Really hope so. And well, thank you. Want to do the raffle?
Yes, please. You've got the. I'll just take. Thank you. Right, we're not done yet. We have got a raffle. So if you did come in, and I think we've got the QR codes around the side. We've got some
a JetBrain license to give away today.